Welcome back to Sketching Quadratics Part 3. I hope you joined us for Part 1 and Part 2. In Part 1, we just did Sketching Quadratics based on transformations of our original y equals x squared or y equals minus x squared parabolas. In Part 2, we focused in on the intercepts of the parabola, so our root and our y-intercept. And now in Part 3, we're going to have a closer look at the vertex point. We'll start back up again today on that same example we left off with, where we were identifying the parts of the quadratic by just looking at the equation rather than plotting points. Let's get started. We can just first look at the formula and say, what's the shape of the curve? Well, my a coefficient, so my x squared term, is positive. That's going to be a positive parabola. That's a U shape or a happy face. Where will it cross the y-axis? It'll cross the y-axis at C. When x is equal to 0, this is 0 plus 0 plus 6. So y will be equal to 6. So I could draw my y-axis in here, but I'm not sure where to draw it. Should I draw it over here and that's 6? Or should I draw it over here and that's 6? Let's see, because it might help if I know where this part of the curve is. Is this part of the curve before or after the y-axis? So where will it cross the x-axis? If I solve this quadratic here, when I set it equal to 0, I can solve it by either the formula, by factorizing, or by completing the square and rearranging. I tried by factorizing because I know two numbers that multiply to make 6 and add to make 5 are 2 and 3. So my two solutions for x, what will make this bracket equal to 0? -2. And what will make that equal to 0? -3. So I've got two real roots, and I know what they are, -2 and -3. So now I know how to draw my x-axis in here. This curve here is going to cross the x-axis in two places, and they're both negative numbers, which means my y-axis should come after that. So this is my y-axis. That's 6. That's -2, and that's -3. What's the maximum or minimum or vertex point? That's the turning point right here down at the bottom in the case of a positive parabola. Now that we haven't looked at yet, and that is something that we have to look at based on just the formula. You're not likely to get that value exactly by just filling in a table of values. In order to do that, you need to work out the line of symmetry of the curve. So for that, it's best to complete the square. Here's my line of symmetry. It's perfectly in between my two roots. If I can figure out what that x value is, I can figure out what the y value is down here, and I'll get my xy coordinate for the vertex. And for that, let's do the completing the square. So what is the vertex point? First, we'll complete the square to work out the symmetry of this curve. Y equals, and then in the brackets, we put an x as the first term, and we're squaring this bracket. When we square the bracket, we're going to get the x squared. How am I going to get the 5x? Put half of 5 in here, so plus 2.5. And then remember, outside of the bracket, we've got the 6. But we're going to get something extra by squaring this bracket. We're going to get 2.5 squared. We don't want that. So plus 6, but minus the 2.5 squared. Let's simplify that. That's going to give us y equals x plus 2.5 squared. That's my completed square. And out here, this ends up being -0.25 by doing 6 minus the 2.5 squared. Now I put these in purple for you so you can clearly see the values that we're looking for. To find the vertex point, we're going to use these values here. The x value that will make this bracket equal to 0 will be our x coordinate, and the y value is going to be -0.25. So basically, when you've got your quadratic in the completed square format, the vertex is found at the point where the value you found is p, let's make that negative. And the q value is your y coordinate. Note that this is the x value that makes the bracket equal to 0, because if this bracket's equal to 0, y will be equal to just the q. Okay, so why do we complete the square? Let's just quickly recap. Computing the square versus y equals ax squared plus bx plus c. Sometimes one is better than the other. To find the roots, for example, we need to factorize or use the formula. So this format's pretty good for that. But completing the square as well, if we've already got this format, we can rearrange and get x on its own. Next, finding the y-intercept. Finding the y-intercept for this format is really easy. When x is equal to 0, just figure out what c is. Y will be equal to 0 plus c. So this format's generally best for that. But if you've already got the completed square format, when x is equal to 0, y is just going to be equal to p squared plus q, right? Because the x is 0. Find the vertex point, or line of symmetry. Now, in this format, we would need to first solve it, so I'm suggesting by factorizing, finding your two roots, finding the line of symmetry, which is right in the middle of those two roots, so you can find that by averaging these two x values, and then you get the middle. Once you've got that x value in the middle, you want to find the y value that goes with it on this curve, so substitute that x value into this formula to get your minimum point. If you've got the completed square version, however, it's just as simple as saying it's negative of this p-value and the y value is the q. The line of symmetry is just where x is equal to negative of this p-value. So just to sum this up, what we need to sketch the curve. Is it positive or negative? Just look at the a value or the x squared term. The roots or the x-intercepts. To find those, you're going to need to solve the quadratic using any method you like. Remember, you might have two solutions, or you might have one solution, or you might even have no solutions. If I had x-axis way down here, this curve's never going to cross it. You have the y-intercept where y is equal to c, so no need to solve this, no need to rearrange it, just the c value. It's the point 0, c, which might be between your two roots, depending on if this is a negative and this is a positive, it's in between them. Or it might be below your root. If this root is positive, the y-axis is at 0. Or it could be above both of your roots. It could be over here. If both of these were negative values, then the y-axis would have to be to the right of that. And the vertex. For the vertex, we are going to need to complete the square. That's the easiest way we can do it, completing the square and using the negative p-value and the q value. Alternately, if you know your roots, you could just find the midpoint of your roots and substitute that x value into this formula. Okay, let's get some practice in. Here you've got loads of different quadratics in different formats. Some of them are already factorized. You may want to multiply them out, or you may want to leave them in the factorized form. But what you need to do is work out the y-intercept, the roots, the vertex coordinate, and sketch the graph based on that. Okay, so hit pause if you want to try that on your own, or if you want to see one example, watch me do the first example with you. So when y is equal to x plus 3 times x minus 3, I don't need to work this out to see that I have already got the roots. That means that when x is equal to negative 3, this will be 0, or when x is equal to positive 3, this will be 0. I know it's a positive parabola, and it's going to cross at negative 3 and positive 3. Now I've labeled down here my y-intercept, which is also right in the middle of my two roots. So I should be able to figure out what that vertex is in the same go. To work out what my y-intercept is, it would be helpful if I expanded this out. And that dots tells me that when x is equal to 0, all I'm left with is negative 9. That's my y-intercept. This value down here is negative 9, which also happens to be perfectly along the line of symmetry of this curve, so that's my vertex point as well, 0, negative 9. Now that you've seen one example, you may want to hit pause and go back and try these for yourself. Right, I hope you've hit pause. We'll go through that again. So our first example, we've got our graphed curve. We see our two roots were negative 3 and positive 3. We saw our y-intercept was negative 9, and our vertex point, or our minimum point, was 0, negative 9. Our next graph, x minus 2 squared. Now this is already a completed square, so from here I could already find my vertex point. But if I expand it out, I might be able to see what my y-intercept is and I might be able to graph that a little bit easier. I can see it's a positive parabola. I can see that the root from my completed square is where x is equal to 2. And I can see that my y-intercept from my expanded version is going to be 4. And my vertex, of course, is this point here where x is equal to 2. This will be 0, and there's no q value here, so q is 0. Next one, here I've got an expanded quadratic. That's a nice easy one for me to find my y-intercept from. I know it's a positive parabola, and I know it's going to cross the y-axis down here at -5. But by factorizing that parabola, I found my two roots, where x is equal to -1 and where x is equal to +5. My vertex point, I can find that by completing the square. That means that my vertex point is going to be where x is equal to 2 and y is equal to -9. Right, next I've got an expanded quadratic again. I know it's going to have a positive shape, and I know it's going to have a y-intercept of +25. If I complete this square, I can see that the root is at the vertex. When x is equal to -5, y is going to be equal to 0. That's point -5, 0. Here I've got a factorized quadratic again, so I can find my roots easily. That's where this bracket's equal to 0, or this bracket's equal to 0. So that's -8 and -2. I've crossed the x-axis at -8 and -2. But by expanding this out, I can find what my y-intercept is, and that's going to be +16. I still need to find my vertex point. It's right in between -8 and -2. -8 plus -2 is -10, divided by 2, that's -5. And I could use that -5 value in the original quadratic to work out what y would be, or I can complete the square. And that's an easier way to find my vertex point. When this bracket is equal to 0, x is -5, and y is equal to -9. So that's the point -5, -9. Next, this is already factorized, so I can easily find my roots at -5 and +1. -5, +1. Now, I know that my y-axis is somewhere between -5 and +1. Not right in the middle, definitely closer to the 1, but I need to find my y-intercept. Let's expand this out. We see that the y-intercept is -5, so I'll label that on here. My vertex point is in between the -5 and 1 and definitely to the left of the y-axis. My vertex point is x equals -2 and y equals -9. This next quadratic, I completed the square for it directly. My vertex is where x is equal to -2 and y is equal to -9. From the original, I can see that my y-intercept is -5. And I could use either of these two formats to try and solve the quadratic to see what my roots are, which are -5 and +1. Next, this quadratic was factorized so that I can see what my roots are. First, I've got my y-intercept is +16. My roots are -8 and -2. And completing the square, x is -5 and y is -9 at the vertex. Right, this is already a completed square. It's a perfect square. That tells us that the vertex point is where x is equal to -5 and y is equal to 0. Expanding that out, I see my y-intercept is 25. And I could use either of those two formats to solve to find the roots. The roots, there is only one of them, and that will be at the vertex, because as you see, y will be equal to 0 when x is equal to -5. Right, this quadratic was given to us in the factorized form, so we know our roots are -1 and +5. Expanding that out, we know our y-intercept is -5. And completing the square, that's halving the b, we know that our vertex point is where x is equal to +2 and y is equal to -9. This quadratic was in the expanded format, so I can see the y-intercept is 4. I completed the square, or factorized, it just happened to be a perfect square, so I can see that the roots are when x is equal to 2. There's only one root, it is a repeated root, so it's just going to touch the x-axis there. And my vertex point is at that root where x is equal to 2 and y is equal to 0. Right, this next one was a dots. In the dots format, you could treat that like a perfect square or a completed square because the x squared is the value that's squared and the -9 is the extra value. So we already know, first of all, the y-intercept is -9. Secondly, we know the vertex point is where x is equal to 0 and y is equal to -9. And we know our two roots. That's where x is equal to -3 and x is equal to +3. Did you notice that you've actually sketched the same graph twice in all of these cases? Because x plus 3 times x minus 3 is this dots. This complete square is the same thing as this expanded out quadratic. This expanded out quadratic factorizes to make this expression. This expanded out quadratic is also a perfect square. This factorized quadratic expands out to give this, and this factorized quadratic expands out to give this. I kind of hope you didn't notice that because I'm sure you had a lot of good practice by doing all of them. Well done, guys.